earthly behavior, earthly behavior, earthly behavior, earthly behavior for MCTV. This is Dr. Walt with Earthly Behaviors for MCTV. We're going to talk this time about the events that happened to me when I was a Navy oceanographer. As some of you may know, I did go back to school after living here for a long time, sold my house and land, and went back to reinvent myself as a scientist. I didn't plan on becoming an oceanographer, but my minor was in oceanography. What I did plan on doing was just being a scientist without knowing very well what that meant. So this story is to show you what can happen to your life if you make the right decisions for the wrong reasons, like I did, and things turned out okay in the end. When I graduated from University of Wisconsin, I had become an expert in air-sea interactions, which is the parameters that move between air and sea. Those parameters are heat, for instance, gas, mostly carbon dioxide, and momentum. Most of you know, especially in a sea-coastal town like this, that when the wind picks up, the waves soon pick up after it. That's the transfer of momentum down to the sea. So I did my experiments on these little instruments here. That's an interferometer above the water there, and that's the way I used to look when I was young. After I graduated, I got 2 job offers. One of them was to go to the University of Miami and work on their ships and bring interferometry to marine science, which I refused because they didn't have the right equipment. Then I was turned on to a job offer from Naval Research Labs in Washington, where I did go. They had a lot of equipment. We were mixed in, for instance, with infrared astronomers, some of whom loaned me their cameras to look at objects that the cameras were not designed to look at. We were looking at water, of course, and we were looking at waves and different ways that water works in waves. The Navy's very interested in that. So as we went along, I found that I was getting more and more involved with Navy things, and when I finished my postdoc after 3 years, I got a job offer from Naval Research Labs and became one of their scientists. So these are some of the things I got involved with there. One of the things that happened is I was introduced to ships that turned vertical. This vehicle, for instance, is called Flip, the ship that flips. And you can see at the top of the picture, that's the way it looks along the dock. It's about 300 feet long, has no engines, no propeller. All the people are on the one end, and the Navy tug tows us out to sea when we're ready, horizontally. It takes about 2 days to go out to where we wanted to go, which is a couple hundred miles offshore. Then we all come up on deck, they flood the stern of the ship, and it slowly turns vertical. You can see in the lower right corner the ship turning vertical. Of course, it's called Flip, the ship that flips, and we needed this vertical stability from like a spar buoy because we're looking for very quiet processes like heat moving in and out of the sea and gas moving in and out of the sea. So we needed a very quiet platform. And in a vehicle like this, the wave fields go right by, the wind doesn't affect it very much, and so we get to put out our booms on either side and hang our instruments from it. We spent about 2 months out there. You can see in the lower right corner there's one of the odd things of the ship, a stairway that leads to nowhere. Just above it you can see one of the hatches in the deck. Now those hatches are designed to keep the seawater out, and they're impossible to lift if you're in this position. When the ship turns to its vertical position, those hatches are very useful. I got involved with other strange creatures in this world of marine research for the Navy. This item is called a spider. It's about 60 feet high, and basically I went up in it and mounted my camera on the little deck up there and started up the thing and drove out into the water. The thing will drive out right through the waves, and the end result is the cabin is suspended above the waves, maybe about 30 feet, depending on the depth, and you can go out beyond the surf and move along and study waves in the infrared with all the time in the world. It's quite an unusual vehicle, and it's quite fun to drive. I got involved in other things, of course, with the Navy. Here, we were looking for mine signatures. I flew on a Beaver aircraft, which is what the Alaskan bush pilots use. There was a camera mounted on an inflated motorcycle inner tube to minimize the vibration of the thing. Also got involved with the Brazilians. We were sent down to Buenos Aires for a little research project. The Navy is involved with all the South American navies because they send a destroyer or a cruiser around the whole South American continent and cooperate with the Chileans and the Brazilians and so forth. So we got involved with them. This in the lower right is not the human spine. It's a picture of the infrared surface of water that is very gently disturbed by two paddles. The two paddles just very slowly close, send a very weak vortex up to the surface, and that stretches the thermal signature of whatever is on the ocean surface. In this case, it was little rivulets of heat that were making the water circulate, and it was stretched out by the paddles into a spine-like shape. In 2000, I got involved with the operational Navy. Up till this point, I had been a research scientist, which meant that the output of my work was a paper in a journal somewhere. In the operational world, it's very different. My job was to transfer research products to operations, which is often called the valley of death because the funding falls away between operations and research, and people don't know which it is at certain times. But I had to go through the research community and find out what might be useful once I found out what the operations of the Navy were like. Naval operations are quite serious. In the research world, if you have a problem or your computer crashes, you can hit the reset button and you start up again. In the real world of operating ships and destroyers and submarines around, there's no time for mistakes like that. The stakes are much higher. People get hurt, expensive equipment gets busted, and you just don't do that. So they're very different out there. The stakes are much higher, too. People can get hurt. So dealing with the research operations was dealing with large, slow-moving objects like this. On the right, of course, is the bow of a battleship, USS Wisconsin. I took the picture because I thought it was kind of beautiful in a hydrodynamic kind of way. On the left, of course, is a picture of one of the carriers going through tests. They do this periodically to make sure everything is tied down below decks as well as above decks, and to test all the systems on the aircraft. These are big ships. This is 100,000 tons. It's 6,000 people on it. Average age is about 20. They can go better than 50 knots, and they don't slow down unless they have to. But big as the ship is, it can be hurt on the ocean. All ships are small on the ocean. This one, for instance, has elevators on either side of it that raise or lower aircraft from the hangar deck to the flight deck up above. Well, if the ship is tilted and there are some waves around, those elevators can come loose. They can be swept clean by the waves of aircraft and people or trucks or whatever's on them. So there's much reason to be careful. Much of the work we did at Navy Weather in Norfolk, Virginia, was where I was stationed, involved ship routing. You have to route ships around bad weather because some ships are much smaller than others and they have different limits of the waves they can pick up on one side or the other. They also go different speeds and they have different missions. The mine layers, for instance, are relatively slow while destroyers are relatively fast. An example of this problem is when the USS Cole was bombed in, I think it was 2003. There was a lot of mistrust in the Middle East at the time, and when the Cole had a hole in the side of it, they didn't want it to be worked on in a shipyard in that area, so they wanted to bring it home. The problem was, how do you bring home a ship with a big hole in it? Well, we borrowed a ship from the Norwegians, this background ship here. It's one of a kind, it's unique, and what this vehicle does, which is a huge vehicle, is to come alongside the wounded ship, flood its tanks and partially submerge itself so there's water on its central deck, and then they either pull the ship over it or move the bigger ship sideways, and they get one above the other, and then it floods its tanks again, pushes air into the tanks, and the whole thing comes back up. They had done this before with other ships, and it works very nicely. The Norwegians make a nice little profit off every time they do it. The problem this time was that the Cole had a large sonar dome in the bow of it. It's very expensive, that dome. That's the highest level of security, and those sonar domes are designed to find submarines and so forth, and they're very important for the safety of all the other ships around them. So they couldn't mess with that thing, so they decided to put the Cole on the ship cockeyed at about a 25-degree angle. That meant that the limits of the waves on each side of the ship were different. So that meant that our ship routers could allow the ship to go one place as long as the waves were coming from one side, but if the wave field shifted to the other side, they had to change course and go in another way. Bringing it back across the Atlantic, of course, meant dealing with the hurricanes. So they would slow down and let a hurricane go in front of them, and then speed up and try to get ahead of the next one. And it took about a month and a half to bring the Cole home, and it was quite a celebration when it did get it home safe. My work was generally in atmospheric science, so I always was involved with the weather part as well as the oceanography. When 9/11 happened, the nation was quite concerned about other terrorist attacks on the mainland. As you may remember, there was an anthrax scare. Anthrax was being mailed to people and so forth. And there was other examples. For instance, somebody blew a toxic cloud into a Japanese subway, and there was other fears in Europe. And so what happened was the Navy weather was the first responders to forecast where a plume of toxic material was going to go in case some screwball blew up a tank of ammonia in a railroad yard or whatever it was. This would also work for accidents. So on the left you can see the different plumes that were, this is an example from a city. They're plumes of different toxicity. The closest, smallest ones are the most highly toxic, and they get less and less as they get dispersed. We need this projection of plumes to be very accurate, because if such an event happened in the United States, one of the responses would be helicoptering in medical people to deal with the victims. Well, you don't want the medical people to land in the wrong place. You want them to land on either side of the plume, especially where there are a lot of victims. This goes for the police and any military response as well. So it was quite a deal to get these plumes just right and to get them known as a reliable means of prediction in the first responder capability. Of course, that scene on the right is from 9/11, but that kind of thing would be repeated if someone did do a toxic cloud terrorist attack. To become an expert in this, the skipper of my command swung around and pointed at me and told me that I was going to join the Army for a few months. So they sent me to Fort Leonard Wood, Missouri to learn Weapons of Mass Destruction, or WMD school. I became an expert in all these hideous things that I didn't like. For example, one of the tests was to show us victims with blood coming out of their nose or ears or mouth or twitching or whatever it was, and have us identify what the class of toxic materials would be. I thought to myself, gee, I'm just a weatherman. I don't want to be doing this stuff, but I didn't have any choice, and I learned what I had to learn. They also brought us in mop suits. It's called a MOPP. It's a big silvery kind of suit with a helmet on it, and you go into their special facilities there that the Army has in Missouri and learn to defuse toxic material weaponry. I hoped that I would never have to do that in real life, and fortunately there was other people in my command that knew it just as well as I did, so I never had to do that. My part of it was simply making sure these models worked as well as we could, and we assimilated the latest weather information into them. Another thing that happened when I was involved with the Navy was the invasion of Iraq. There's lots to say about that. I personally am not in favor of the war in Iraq or a war in Afghanistan, but I certainly don't see any reason why our people should be in danger unnecessarily. So I was happy to help keep them safe. If you remember what happened, the armies, the tanks, and all those stuff invaded from the south, and they were about halfway through to Baghdad when a big dust storm enveloped the area. Now, dust storms are serious business out there. This is not a little something that makes your contact lenses gritty. Now, these things really shut the whole place down. And we had dust storm models in the Navy and in the Army that was going to predict when the dust would settle. And of course, the combat commanders were always on your tail to say, when is it going to settle? Is it tomorrow going to be okay? With an Army that has precision-guided munitions, some of which are guided by lasers, you have to have reasonably good visibility, or at least know what the visibility is, so that you can tune the weapon to hit the target. So the dust storm models didn't work so well. We told the combat commanders that it was going to clear the next day. They were all ready to go, and the next day it didn't clear. And we told them on the third day it was going to clear, and it didn't clear then either. So eventually it cleared, and the incident was forgotten, except to me, because the problem landed on my desk. You have to improve these dust models. So I had some friends out in the field, and my command knew some people out there, and we basically studied dust for a while, or I did. And we found that the models had a settling rate of dust that was a given from dust that was generated in the United States. Dust, as you may or may not know, has hard particles and softer, smaller particles in it. And the hard particles fall out relatively quickly, whereas the light ones have a settling rate that can take them many hours to settle. They're also stirred up again by heat and by winds blowing over uneven ground. So it's quite a difficult forecast situation to tell when the dust is going to settle. The friends I had over in Iraq, we went to the source areas of all the dust. It turned out that dust comes from different source areas, little deserts and little dry areas. And they got a bucket of dust from each of the 7 source areas. So I managed to go out there, get the buckets of dust and shrink wrap them all, and was going to bring them back to the United States to give them to the modelers of dust, who happened to be mostly in the University of Colorado. And when I got to the United States, the customs agents, of course, wouldn't let me come because they said this is not clear. This could have bugs in it. It could have pollen in it. It could have a virus in it. It could have the boogeyman in it. So me and my 7 buckets of dust went back to the Middle East, and we managed to get the buckets onto a destroyer that was being recirculated back to the United States anyway. So I guess I'm a dust smuggler if it comes to that. But dust is also a big problem for regular operations. You can see from the helicopter landing there that it takes a while for things to settle down after one of those babies comes in. Also, forecasting dust for normal operations, including precision-guided munitions, is difficult. Some of these desert areas are relatively high altitude, and things operate differently at high altitude. They also can be quite cold, which changes the pattern of uplift and descent that convection generates. And so it became a problem that I was able to help with in my own small way, but basically left it behind. What I didn't leave behind was hurricanes. In Norfolk, Virginia, like in the whole East Coast, you have a problem with hurricanes. We have our problem with earthquakes here in California, but we don't get a warning for earthquakes. In the hurricane business, they do. They have forecasts that go out 4 or 5 days, for instance. That's one of the whoppers that ran into Norfolk, Virginia. Flooded my house, too, along with everybody else's, it might say. And it's a real head on the chopping block forecast. I mean, you have to be right. The ops floor at the Navy Command, Navy Weather Command, is a big room with great big screens, and there's a lot of activity as people route ships back and forth across the Atlantic. At any one time, there's, say, 60 ships being routed back and forth. And they get phone calls, say, which way do I go to get out of this big wave situation? So it's a big deal. When a hurricane approaches, though, you have the admiral's staff and anybody who ever had a weather class in their life coming onto the ops floor, unless we can keep them out, and giving us advice about where it's supposed to go. Hurricanes are difficult creatures. They have their own moods. They have a tremendous inertia. They tend to go where they want to go. once they get built up. And of course, there's always proto-hurricanes or very young cyclonic storms coming across the Atlantic. So in the weather business, you have to number each one so that you can keep track of its growth. And some, of course, curve out to sea and never come back, and others come on shore and cause a lot of problems. Well, in a huge naval base like Norfolk with 60 capital ships, and there's a whole commercial thing with coal barges and container ships and all kinds of stuff, you don't want to be in the shallow water when that big baby comes over the line. So knowing exactly where its path is, knowing exactly what the winds are going to be, knowing where the eye is going to go, all that stuff is crucial. They have very impressive meetings before this, of which I was privy to, just sitting around, and I'd say there's like 40 people sitting around. These are admirals of the fleet, these are port captains, these are people who control big barges of coal and other products, and they all would want their tugs at the same time, of course, so they have to apportion the tugs. There has to be some order as they go out the gate to get out to sea ahead of the hurricane, because they can get in each other's way, bang into each other, and cause more damage than they would have gotten otherwise. So deploying 60, 70, 80 ships out before the hurricane comes across is one of the problems. Here's some of the deployment schemes. Up in Norfolk, they go straight out to the east, and then they go south, and then they come back. Down in Mayport, where we have one carrier down there, they have a more elaborate and further plan. Some of the captains of the ships wanted to come out the port in Mayport and cut south and kind of dodge around the hurricane, but we didn't know the path well enough, and they could meet it head on if we were wrong. So we had them go out ahead of us, ahead of the thing, and let that whopper go by. I might point out, too, that the crews on the naval ships have to run their ship. They go out and run their ship. So that means that their family is left behind alone to deal with the hurricane on their own, including evacuate them. Well, as things went on, I got involved with the special operations, spec ops they call it. That's all the guys from each service, the Army Rangers and the Navy SEALs and so forth, that do those unusual things that are so romantic and so difficult. They can ride horses, speak in several languages, and they're quite adept at parachuting and aqualunging and all kinds of things. They were very impressive people, I must say. It was like being in a room with leopards. They seemed so in shape and in tune and alert and alive that I envied them a little bit. If I was 40 years younger, I would have maybe joined them. These are some of the Army Rangers coming down there, adjusting their chutes. They can land without even bending their knees if they need to, and land on the same handkerchief 8 times from 20,000 feet. They're quite adept. They said they can land on top of a building and just wait there all night and be there when you come out for breakfast. I don't know about that. That'd be a little difficult, but I got to work with some of the problems they have. One of them was ducting. They have ducting is generated by, and you go up, you know the regular weatherman sending his balloon up with a little cardboard radio on it. Well, he's trying to get the humidity measurements at all altitudes. And when those humidity measurements change quickly, within 100 feet or 50 feet, that's called a duct, D-U-C-T. Ducting is a problem because it will refract electromagnetic waves and make them go in directions where you don't want them to go. For instance, a battle group commander has his radar sweeping around the whole horizon. He wants to know that there's no threat out there in any one direction. Well, if his radar goes out and then goes 30 degrees off to the side, he needs to know that. He needs to know what's there. The same thing with the SEALs. If they go into a beach covertly and quietly, they want to know that there isn't a lot of cell phone traffic. They'd rather know that there isn't anybody listening to them or watching them or knowing that they're there. So they want to know about ducks. So unfortunately, the only way they had to learn whether there was a duct on a beach that they were going to go into was to send some poor devil in all by himself or herself to the beach in the night and to lurk around in the rocks and kind of hide there. And then at night, he'd launch a balloon And it would have a little cardboard radio, but it would report back to the submarine, and they could tell whether there was a duct involved or not. Well, of course, all of them hated this job. I mean, nobody wanted to go in alone. So the problem came to my desk. I tended to get the problems that hadn't been solved yet. So what we did with this one was we made a little glider about this long with its wings folded back next to its body. The glider would slide out the flare tubes of a C-130. Most airplanes who fly around the Middle East have tubes in the back that you can shoot infrared burning flares out the back. That would decoy any infrared shoulder-fired missile that somebody was trying to shoot the airplane down with. So these flare tubes are very convenient. We designed the airplane, this glider, no motor, to fit out the flare tube. What it would do when the airplane was, say, 20 miles from the beach and 25,000 feet, way away, nobody could hear it, nobody could see it. We squirt this little charmer out the flare tube and its wings would pop open. GPS was already programmed into it, so it would circle around and look for the direction it was supposed to head in, and then it would glide the 20 miles. Easy to do when you start 5 miles up. And it would come to the beach where it was programmed to be and would slowly circle around, giving measurements all the time, sending them back to the sub, drop into the water, give you the water temperature, very important for a swimmer, and then sink. That's as covert as we could make it, and the SEALs were very happy with that little item. After I retired in 2005, I got involved with the intelligence community. That was a very different world. I was used to being a scientist involved with satellites, which meant that I went to a conference somewhere in the world, and there was people from all over the world there. So naturally, I developed a network of friendships with people all over the world. Well, when I got on the intelligence community, they immediately said, you don't talk to anybody who's not a U.S. citizen, and if you do, you write us a report, which kind of throttled back my interest in being a network point for international research. Many doors are closed in the intel world, and if clearances are high enough, and mine were, many doors opened up as well. So I can't talk about most of the stuff that happened there. One of the things that might be of interest that we worked on that is unclassified is that they have a project to forecast where wars will break out. Of course, there's many factors in a war, can be many factors. One is a religious factor, political, economic, so forth. I got involved with the environmental factor, specifically droughts. When a drought happens, people get an empty belly, they get irrational, overthrow their governments, or go across the border and take somebody else's stuff, and it's a problem. So forecasting where the droughts would occur 10, 15, 20 years ahead was part of what I worked on. We ran a suite of climate models, and the best ones we could find is fairly expensive. Computer time is very expensive for these big, complex models. And we managed to find places on Earth, and this is not an example of what it turned out. We found places on Earth that were much more prone to drought than we realized previously. Western China was one of them, Western Australia is another, and the American Southwest doesn't look so good either. And these are real droughts. This is not like a few years of dry weather. This is a semi-permanent change. Another project I got involved with, and you probably think this is funny, but I don't. It's the HAIR project. Yeah, I know. The HAIR project was this. We wanted to develop a way to take a person's hair, sample a person's hair, giving willingly, of course, and run it through a mass spectrometer, and that would see the isotope ratios in the hair, and that would show us where the person has been, because there are maps called isoscapes, and we can say, well, this isotope ratio belongs here in Connecticut, and this other one belongs in Syria. We got involved with trace elements as well, so if you were downwind from a lead smelter, or there was some kind of chemical in the water of the area you were living in, this would show up in your hair after a while as well. This got to be pretty good. We found that it had been used before. The anthropologists used it when they studied skeletons of people's bones. They would drill into their teeth or finger bones and find out what the isotope ratios were at different layers in the bone, and that could tell them something about where the person was living. The ornithologists also used isotope analysis because they wanted to find out where the migratory patterns were of the birds they were studying, and they could tell where the bird has been by looking at the isotope ratios. So the final result of 20 years of working for the military is still the same reason I got into it. Science is fun. Even military science is fun. You can see the kind of toys I got to play with. War is less fun, and there's higher stakes, but it's still very interesting. In fact, it's more worthwhile, frankly, to work with the military than I found working with civilians. But now you know, that's what happened to me. You know life's a roller coaster. You keep your ticket stub, they may be asking for it, and someday we'll find out what happened to you. That's Dr. Walt with Earthly Behavior for MCTV. Earthly behavior, earthly behavior, earthly behavior. This is Dr. Walt, Earthly Behavior for MCTV.